Every time you ask an AI chatbot a question, somewhere in the world a data center is working. Rows of servers, cooling systems, backup power, chips running at enormous scale. To most users, AI feels weightless. You type a prompt, you get an answer. But behind that answer is a physical machine consuming real electricity. And as AI grows, one question is becoming harder to ignore. Who pays for all that power? At first, AI looked like a software revolution. People talked about apps, chatbots, automation, productivity, and jobs. But now the deeper story is becoming clear. AI is also an infrastructure revolution. It needs data centers. Data centers need land. They need chips. They need water for cooling. They need transmission lines. And above all, they need electricity. A lot of electricity. This is why AI is no longer just a tech story. It is becoming an energy story, a utility story, and a household finance story. The first problem is demand. Data centers are being built at a scale that many power grids were not designed to handle quickly. In some regions, proposed data center power requests are so large that they look less like buildings and more like new cities appearing on the grid. That creates pressure. Utilities may need to build more generation, upgrade transmission, strengthen substations, and plan for huge new loads. All of that costs money. And the uncomfortable question is whether those costs are paid only by big tech companies or whether some of them eventually flow into electricity bills for ordinary customers. That is why people are starting to worry. They may not use AI heavily. They may not own shares in big tech. They may not work in the industry. But if the local grid needs expensive upgrades, they could still feel the effect. The second problem is timing. Building an AI data center can be faster than building the energy infrastructure needed to support it. A company can announce a major project, but power plants, transmission lines, and regulatory approvals can take years. When demand arrives faster than supply, the system becomes stressed. And in energy markets, stress usually means higher costs or reliability concerns. The third problem is who gets priority. If a region has limited grid capacity, should it go to homes, factories, hospitals, or data centers? That question sounds technical, but it is deeply political. AI companies argue that data centers bring jobs, investment, and economic growth. Local governments like the tax revenue, utilities like large customers, investors like the infrastructure boom. But residents may ask, why should my bill rise so a tech company can run more servers? That tension is going to grow. The fourth problem is energy source. Many tech companies promise clean power. They sign renewable energy deals. They invest in solar, wind, batteries, nuclear, and other solutions. But electricity grids are complicated. If new demand arrives faster than clean supply, the system may rely on natural gas or keep older power plants running longer. In some places, fossil fuel plants are being proposed or extended because data centers need reliable power all day and night. So AI may accelerate clean energy investment, but it can also increase pressure on fossil fuel generation. Both things can be true. That is why the story is not simple. AI can help optimize energy systems, but it can also consume more energy. AI can create economic value, but it can also raise local costs. AI can make companies richer, but households may wonder whether they are subsidizing the infrastructure behind it. The fifth problem is transparency. Many people do not know how much power data centers need until a project appears near them. Sometimes agreements between companies, utilities, and local governments are complex or hard to understand. Residents may feel decisions are made before they even know what is happening. That creates distrust. When people see electricity bills rising and then see massive AI facilities being built nearby, they connect the dots whether the full economics are clear or not. And that perception matters because energy is not optional. You can cancel a streaming app. You can delay buying a phone, but you cannot easily cancel electricity. If power bills rise, families feel it immediately. This is why the AI electricity story has viral potential. It connects the future to the kitchen table. Most people do not care about semiconductor supply chains in detail, but they care if their monthly bill goes up. So what is the solution? First, big energy users should pay their fair share for grid upgrades. If a data center requires new infrastructure, the cost should not quietly shift to households. Second, power planning needs to move faster and become more transparent. Communities should understand what is being built, how much energy it needs, and who pays. Third, clean energy must scale with AI demand, not after it. Fourth, data centers need efficiency pressure. Better chips, better cooling, smarter scheduling, and location choices can reduce strain. And fifth, the public needs to understand that the digital world is not weightless. Every cloud has a physical cost. Every AI model has a power bill. Every server sits somewhere, uses something, and affects someone. The climax is this: AI may feel like magic on your screen, but the bill for that magic may arrive through the grid. And if the rules are not designed carefully, the people who benefit the most from AI may not be the same people who pay the costs. That is the real danger. Not that AI uses electricity. Every technology does. The danger is building the future so quickly that ordinary people are left paying for infrastructure they did not choose and do not control. AI is coming for the world, but before it changes everything, it may change something very ordinary first: your electricity bill. There is another part of this story that most people do not see. The grid was built for yesterday's demand, not tomorrow's AI race. For decades, many countries planned electricity systems around homes, factories, offices, hospitals, and ordinary business growth. But AI data centers can arrive like giant new cities of electricity demand. They may not have millions of residents, but their servers can require enormous power every hour of the day. That creates a planning problem. If a region wants the jobs and investment from AI companies, it may approve projects quickly, but electricity infrastructure is not a software update. Transmission lines, substations, power plants, and grid upgrades take time, land, permits, and money. If tech companies pay too little, ordinary households may end up subsidizing the AI boom through higher rates. If they pay too much, projects may move somewhere else. If governments delay too long, they may lose investment. If they move too fast, the grid may become more expensive and fragile. This is why AI electricity is not just an energy issue, it is a fairness issue. The people using AI tools may never see the server farms, but if the local utility bill rises, they will feel the cost of a technology that was sold as invisible. And in the end, finance is not just about numbers on a screen. It is about the choices we make, the systems we live in, and the future we are trying to protect. If this video helped you see money a little differently, subscribe to the channel for more clear and honest finance breakdowns. Thanks for watching.